Now let us see how to solve this problem. This is a beam of span 4 feet and you have a partial UDL acting on the beam, that is 4 kips per feet, that is 4 kilopounds per feet, and this load is starting at 2 feet ending at 4 feet. Starting at 2 feet ending at 4 feet. These distances are referred from the back node, and this support is a pin support and this is a roller support. If it is a roller support, you will not have Fx, you will not have Mz, you will have only Fy here, that is you will have only this reaction here. So for that reason this roller support instead is defined as fixed, but Fx is not there, Mz is not there. And the question here is find the deflection at B. There are two ways in doing this. Let us see how to solve it. Now I'll say File, New, I'll say Plane, I'll choose feet and kips. This is feet and kips. Because the problem is in feet and kips, I've chosen these units. I'll say Next and say Finish. Now we need to draw a beam of span 4 feet and say Escape and close this grid. Let us verify the dimensions. This is a beam of span 4 feet. Now let us define the cross sections. I'll say this is 1 feet and ZD as 0.75 feet, and the material is concrete. I'll say Add. Once you say Add, the property that you see here will be in meters. That means this units will be in the units that we have chosen while we are installing the software, that is the default units, SI units. So if you say Edit, again you can see this in feet and it's not a problem. Now you can assign this to this member and say Assign. Now let us define supports. I'll say pin support. This is pin support. I'll say Add. I'll again go to Create. I'll define another support, that is roller support. That's nothing but fixed, but Fx is released, Mz is released. I'll say Add. Now you can pick this one and give it to this node and say Assign Yes, and we can pick this one, give it to this node and say Assign Yes. Now let us define the loads. Let us pick this one, Loads, Add and say Close. Now we need to define a load of 4 kips per feet. It's a partial load from 2 feet to 4 feet. Now let's do that. It's a member load. It is minus 4 kips per feet, starting from 2 feet ending at 4 feet. So this is how we should give the partial UDL. I'll say Add, I'll say Close. Now this one has to be given onto the beam. We can say Assign to selected beams and say Assign. Now that's what we have. You can adjust this load by picking the load icon here. Now let us analyze the problem and see the results. Now the question we have here is, we need to know the deflection at B. That is the question. Now of course this is the deflection diagram. Let me remove these dimensions, and if you say results, view value, beam results, maximum displacement, that is maximum resultant displacement, you will get this 0.071 is the maximum displacement for the beam. This may be occurring at 2 feet or something or somewhere else, but we are keen in not knowing the maximum. We are keen in knowing the deflection exactly at this point. Now how to do that? Let me switch off this. I'll take the beam cursor and I'll double click this member or you can say properties. Now here you have deflection. This is the icon. By default, here you will have X direction deflection. You pick this Y direction. Now you type 2 feet here. You will understand that this is minus 0.072 millimeters. Of course, this incidentally is a maximum displacement. But if you're asked to find the deflection at any point, you can find something like this. You can type in the value here. At 3 feet, what is the deflection? This is the deflection. So this is how you can find the deflection. There is another way to find the deflection. What I'll do here is, I'll define a node here so that this load will be acting on the full length of the member BC. If I define a node here, and then I'll request STAD for the nodal displacement. That you can see in the next file.